Welcome back to part 2 of the tutorial series on Catatumbo. My name is Sai Pulla Butla. I am the author of Catatumbo Framework. Um, in part 1, we have covered the prerequisite, which is to have a Google Cloud project with Cloud Datastore enabled, and we have also got credentials file downloaded so we can access the data store remotely. And then we also created a sample entity or manually using the Google Cloud's console. So in part 2, which is what I'm going to cover in this particular session, we'll actually dive into some coding. So we'll first set up a Maven based project. I'm going to use Eclipse as my IDE, but you are free to use any IDE of your choice. You need Java 1.7 or up. I believe I'm going to use 1.8. And then in this session, I'm going to show you how to connect to the Cloud Data Store, the one that we actually set up in part 1. And then I'm also going to show you how to connect to Datastore Emulator, which is a little nice utility provided by Google, so you can emulate a data store on your local system, which is pretty handy for development purpose. And then I'll walk you through how to perform CRUD operations. Basically, we'll create some sample entities, retrieve them back, update, and deletes. And then we'll focus on the following annotations: entity, identifier, property, ignore, secondary index, and decimal. These are some of the basic annotations that you would be using um, when using Catatumbo. All right, so with that, let's jump into, let me open my Eclipse here. All right, I have this brand new workspace, so I'm going to go ahead and create a new project. As I said, we are going to use Maven to make our job easier. So all the dependencies are downloaded automatically. And let's go ahead and I'm going to go with the quick start arch type. Go ahead and click next. For the group, I'm going to just use com example. And for the artifact ID, I'm going to call it tutorial. For my package, I'll just make it com example catatumbo. Let's go ahead and finish. All right, our project is now created. Now we need to add catatumbo as the dependency. So I'm going to just go ahead and add a dependency. You can of course edit the pom.xml and manually add the dependency. Basically, you're looking for com j methods as the group ID, and artifact ID is catatumbo and the version that you want to use. So let's go ahead and add com j methods 1.1.3. Make sure you're using the latest version. As of now, 1.1.3 is the latest version. All right, now you can see you have the catatumbo dependency and then all the cyclic dependencies, which are from Google's cloud APIs. So with that, our project is now set up. So we should be able to, oh, there is a build path problem. Let's fix that. All right, so the first and foremost thing, let's go ahead and create a model class. In this example, I'm going to use employee as my model class. So basically we'll be persisting employee entities. So let's go ahead and create a brand new class. We'll call our class as employee. And then let's just add some fields here. For now, I'm going to just create an ID of type long, and then employee will have a first name, a last name, and let's also do a Boolean property to say if the employee is currently active, and we'll add a big decimal for the salary. All right, these are the fields that we would like to play with, and let's go ahead and generate setters and getters, or accessor methods for all these fields. So I'm gonna just select all the fields, go ahead and do OK. So now we got our setters and getters. I'm also going to do a toString method from all these fields. So basically it's going to show me a string representation of my objects. We'll use this for doing printouts of the objects to see what we're sending to the data store, what we are getting back, and so on. All right, so our model class is ready, and now pretty much we should be able to persist it. I'm going to use this app here as our main class. So let's go ahead and so the first and foremost thing is we need to have Entity Manager in order to access the data store. Entity Manager is an interface provided by the Catatumbo framework. So let's go ahead and see how we can get Entity Manager. In order to get an Entity Manager, you would use the factory, Entity Manager factory, and which is a singleton class, and you have a variety of options on how to produce your Entity Manager. You know, basically you can supply what the configuration. For my case, I'm going to use this project ID and credentials method. Remember the project ID that we created in the part 1. So let's go back to console, Google Cloud Console, and let's see what our project ID is. So that's our project ID. And then we also have our credentials file downloaded, which is in my downloads folder. For making it a little simple for me, I'm just going to paste that credentials file to the project. You probably don't want to do this in a production environment. And I'm going to just rename it to a simpler name. So I'll just call it catatumbo tutorial.json and send our file now. All right, so basically we're saying, hey, I want an entity manager for this project, and these are my credentials. You know, the credentials are in the JSON file, which is a private key. Once you have the entity manager, you can do all sorts of uh, things with the data store. For example, you can use create entity queries, delete objects, a bunch of variations for the delete method here, executing queries, inserting entities, single entity, multiple entities, loading entities. So pretty much entity manager is your uh, access point for the data store. Now let's go ahead and move this entity manager to a static variable so we can access it from all other methods. Alright, we'll just leave it there. And then em is that. Alright, so now let's go ahead and create a brand new method. Private static insert. And we're gonna call the insert from the main method. So we want to insert an employee object, so let's create an employee object. And then let's populate some of the fields, set first name, and set the last name also. Let's see, we want to leave the active as true, and then we'll set the salary now to it's a big decimal, so new big decimal, 50,034 $340.67. So now at this point we can just pass this employee object to our entity manager and say, hey, insert this. Now this is not going to work because number one, the framework is Catatumbo framework does not just persist any object unless the object has some specific annotations. So just to for seeing what the framework does when we try to insert this employee, let's go ahead and run our app class. Now, as you can see, we got an exception here, and the message is employee class must have entity annotation. So that's a bare minimum requirement. In order to make your model class persistable by Catatumbo, your model class must have entity annotation. So let's go ahead and add the entity annotation. So now that we have added the entity, let's go ahead and try to insert again. I know it's going to fail again because as I said in my previous session, every entity must have an identifier. And within this employee class, we don't know, or Catatumbo framework doesn't know which one of these fields is ID, or if you even have an ID. So one of the fields in the entity class must have an annotation of identifier. So since we have this ID here, let's indicate that is the identifier. All right, now those are the two bare minimum things that you need to do in order to make your model class persistable. Now when we run the app, we should be able to insert the employee. So there are no errors. Of course, we didn't do any system outs or anything to see the output, so the console is blank. But let's go to the Cloud Console and see if we have our employee object. So this, let's just type our entity name. Sure it is. So we just created a brand new entity with John Doe. He's still active and his salary is so much. And there is an automatic ID that's generated for this entity. So that's pretty much it. I mean, now you can do all sorts of operations, not only insert, but also retrieval, updating, deleting, and so on. So let's go ahead and see how you could load an object. Now that we know the ID, all right, well, we're still going to use em, and then we are going to use load. Now, which you need to tell the ID of the entity that you want to load and the expected type of the entity so we can map it and return the right object. So we're saying the expected type is employee and the ID is, we're going to just copy it from here. So that's our ID, so let's just pass that ID. Now this method returns an employee, so okay, let's do a sysout on emp, and then we'll change our main method to from insert to load. All right, so let's go ahead and run this. Okay, so we were able to find the employee with the given ID, and we have all our attributes retrieved from the data store. So now let's talk a little more about, well, before, so this is how we connected to the remote data store. Now, one of the topics that I was going to cover was how do we use the local Datastore Emulator. Datastore Emulator is a part of Google's Cloud SDK. First, you need to go to this particular link here, and there are for your platform, just use one of the quick starts and follow the instructions to install the Google Cloud. And then run the gcloud init command. Once the gcloud is installed, you would initialize the gcloud tool. You will be prompted to log into Google account to complete that setup. So finish that. Now, to start the Datastore Emulator, this is the command. Of course, you can find the details about this command in the official documentation. But basically we're saying start the Datastore Emulator at this, use this data directory. In this case, I'm setting it to dev data gcd, and then we are starting it on localhost port 9999. So when you first run this command, you may be prompted to install the emulator component because it's a add-on component to the gcloud tool. Let's go ahead and copy this command and run it from my so I'm going to open up my terminal. Oh, there it is actually running, looks like. So I'm going to just kill it and So pasted the command. Now it says dev app server is running. If you see that message, it's basically setting the host and port to localhost 999. And when you see that message, that means your emulator is successfully started and you can connect to it. Now, how do we connect to the emulator? So let's go back to our code, and instead of let's comment out this line now, and let's use a different factory method. Entity manager factory still, and then create a local entity manager, and then we need to supply the host and port, so we'll say localhost 999, and let's go ahead and do the insert this time because we probably don't have any data there. All right, so that's the only difference. You're still using the entity manager factory to get your entity manager, but you're using a slightly different variation to indicate that you're requesting an entity manager for the emulator. Let's go ahead and run that. Yeah, I should add some system outs to the insert method here. So let's do that first. So I'm printing both input and output. Input is the employee object that we're sending in to the insert method, and output is what the return value is from the insert method. So we can see the difference. Let's go ahead and run again. All right, so the input was, we did not set an ID, so it is 0. We sent John Doe true, and output is we got an ID of 4. Now the ID allocation in the Datastore emulator works different than the actual Datastore. If you notice, the actual Datastore IDs were pretty long, like this, but the emulator typically starts out with 1, 2, 3. It's sequential. So if we check our console now, there are some messages, and the last message is time to persist data is 1 millisecond. So we are sending requests here now. Unfortunately, there is no way to view the data that is in the emulator. Hopefully sometime in the future Google will provide a tool to access this data store, but we can definitely do a query back on the local data store and make sure our employee is still there. So since we created a ID of 4, let's go ahead and try to load that instead. All right, so we are basically loading from the local data store with an employee ID of 4. So let's go ahead and run the app, and we did find the record, and those are the details. So that covers both. Now you know how to connect to both the remote and local data stores. Now let's go ahead and talk a little more about this insert method here. So the insert method returns an employee object, and the reason is the catatumbo framework does not change anything in the passed in object. So your employee object remains as is. A new employee object is returned, which may reflect some changes. For example, you're seeing an ID populated in the return value. Now let's go ahead and do a quick update. So we can switch back to the remote data store, so we can watch the data now, because with local we cannot see the data. So I switched it back, and for the update, um, let's get the ID for employee. So we're first loading the employee, and we'll make some updates. So let's pretend that this employee just got a raise. So we'll just set a salary of uh, 60,000 even. All right, so now let's run the update method instead of all right, so app. Now we didn't even send the did the call to the update. So let's do that first. And again, the update method also returns an employee object. So now let's print out the input and output. All right, let's go ahead and run this one more time. So we sent the input with the 60,000. We got the output with the 60,000, and we still have the same ID. So let's go and check the data now. So our salary has been reflected to 60,000. If you want to, same thing with deletes. Let's just copy this. So we're still going after that employee. Well, we don't need to load the employee in order to delete, so we can just say delete entity class and ID. So delete does not return anything, so we can remove our return value. All right, so now if we refresh, the record is gone. So that's the basic CRUD operations. Again, feel free to um, check the Java doc and try out variety of methods that are available in the entity manager. For example, you can insert multiple entities at one point, with a single call by passing a list of objects. You can do the same thing with updates, deletes, and so on. Now let's go ahead and see what else we wanted to cover in this. So we covered the Maven project, Google Cloud Datastore, We connected to the local emulator. We covered the CRUD operations. Now let's learn about these individual annotations. Let's start with entity annotation. So let's go back to our employee class. So we added the entity annotation to make it persistable. There is one attribute that you can add to this annotation, which is called kind. Again, kind is just like the table name. So by default, Catatumbo assigns the class name as the kind. But if you want it to be different, you can specify the kind here. So now when you persist or try to retrieve an object, it will look in a kind called EMP in the data store. So let's go ahead and do that. So now I'm going to comment out this, and let's go ahead and insert one more record. Okay, we just inserted a new record with that ID. If you refresh now, since you're still looking at employee kind, there should be no change. Now let's see if we can find EMP. There it is. So now the kind is actually EMP, as the key shows. So that's pretty much about the entity annotation. Now let's talk about the identifier annotation. So let's go back to Eclipse. Now identifier has one attribute, whether or not you want to auto-generate. So by default, auto-generated is set to true. Now IDs can only be of two types. One is numeric or string. When it is numeric, you have the option to use either primitive long or the wrapper long object. Otherwise, for strings, you just use the java.lang.string. The catatumbo framework can auto-generate IDs for either of the types. When you use a string type, the generated ID will be a random UUID. If you are using a numeric identifier, the ID is assigned by the actual data store. So you can say auto-generated is false. In that case, you're expected to manage your own IDs. So if you try to insert an employee again without setting the ID, you're going to get an error. So identifier is not set or valid for employee. And then auto generation of ID is explicitly turned off. So since you're turned off, Catatumbo framework basically doesn't send the entity to the data store. It just halts during validation phase. Now you can also make a string identifier. So let's just change it to string, and auto generate is true. Let's fix our method here. Instead of long, we're going to return string, and we're going to accept a string in the set ID. So now since we turned on auto generated, let's go ahead and delete this record. Okay, now let's go ahead and run our app again. So when we sent the ID was null, but since we said generate an ID, framework generated a random UUID and persisted your entity. Now let's go ahead and refresh. Now it says the name is our UUID that we generated. All right, that covers the identifier annotation. Now let's talk about the property annotation. So any field that's being persisted is a property. So first name is a property, last name, active, salary. By default, all fields in your model class are persisted by the framework as long as there is a corresponding getter and setter methods. So if either of the methods are missing, the field will be skipped from the persistence. Otherwise, it's going to be persisted. Now you can also mark a field as explicitly as a property. So you can just say property. In this case, now first name requires, you're required to supply both set first name and get first name. Otherwise, the validation is going to fail. Now let's see what attributes this property annotation has. There are two. One is indexed, the other one is name. So name is basically used for overriding the default name. By default, we use the field name as the property name in the data store. So if you notice, let's go back here. See, those field names are exactly same as your field names in the entity class. But if you want to keep them short, or if you follow specific naming convention, you can definitely override them. So let's say I'm going to call this F name, and now if we run this, let's go ahead and clean up our entity, delete, and run. Let's go ahead and refresh our data. So now our field name is changed to F name. You can also say by default all properties are indexed unless you turn it off. So if you look at our entity here, see, all properties are indexed. But you can turn it off on a specific property if you are sure that you are never going to need a search on that field or sort on that field. So think multiple times before turning off indexing. Once you turned off the indexing on a property, that property cannot be used in a composite index either. We'll cover composite indexes later on in this tutorial. All right, so let's turn the indexing off and see. Well, let me show you what indexing means by running a real quick query here now. So this, you can do select queries based on GQL here. Select star from EMP where F name equals John. From all right, so now that John is there, it was able to find the record and show the result. But let's go ahead and delete this record and insert a new one. But now we're turned off indexing. So let's go ahead and refresh. If you look at the record, see, John is not indexed, which means when you run the same query that we ran, there is no match. So that's what those property indexes are. Now, one key thing to notice is these property indexes are applied on each entity separately. So just because, let's say I'm going to turn this back on and run the app one more time. to demonstrate what I'm going to. So now we have two records. For the first one, first name is not indexed, but for the second record, it is indexed. So don't think of these indexes as table level indexes in RDBMS. These indexes are applied on every entity that you're going to write. So some entities can have first name indexed, some which is may not have an index turned on, which is perfectly legal from the Cloud Datastore point of view. But you have to decide what you need to do for your application, which is a separate story. So if we do a query now, we're just going to get that one record where we indexed the first name. You're never going to get the second record still. So if you want to ever see the second record, you have to rewrite that other record with indexing turned on. All right, so that covers the property annotation. Now let's talk about the ignore annotation. Let's go back and let's say we do not want to persist this active field, even though we have the field is defined, it has a setter method and getter method, which means it qualifies in the persistence operations. But we specifically, as a developer, I'm saying no, don't persist this field ever. That's what the purpose of ignore annotation is. So let's go back, clean up our data again. And now let's run. So if you go back to the data store, we got only 3 fields now because we ignored the active field. That's ignore. Let's see what else. Oh yeah, we wanted to do the secondary index. So let's see what secondary index is. Now, every property has an indexed true or false, which is great. However, let me show you a query again. So selecting on the first name by John is finding a record. However, when I just do a lowercase j and run it, we don't find anything. And that's because everything in the Google Cloud Datastore is case sensitive. Unfortunately, you don't have functions like SQL offers, for example, upper or lower to do the transformations on the fly. So, um, if somebody types John in this case, they will never find any record. So secondary index is something that's a feature of Catatumbo to actually create a secondary index so you could do case insensitive queries. Basically, the secondary index will create a new property either in uppercase or lowercase. So John will be converted to all lowercase. So your queries, when you're doing a query, you can always send in lowercase values. So let me show you how that works. So we're just saying adding secondary index as the annotation, and optionally you can specify a name, which is basically what should be the name of the property for this secondary index. If you don't send anything, the framework assigns a name. So let's just run this and see what we get. Let's go ahead and delete the data that's there. And now let's run the app. There is an additional property here, $fname. That's the secondary index. Now notice the value is all stored in lowercase. So you can basically have a consistent query now. Whenever you do a query, you just set your application to do the query in lowercase, but yet use this for your, to display it on your app with a capital J and so on. So that's the purpose of secondary index. Of course, you can change the name of this if you don't like the $fname, and if you want to call it first name index, you can do so in the annotation here. So you can just specify a name. All right. Now, the last annotation that we listed on the slide was about decimal. So Cloud Datastore does not have a true decimal data type. So which means you cannot say, I want to have a decimal field of uh, 15 precision with, 3 digits after the decimal point. All the, all the Cloud Datastore has is either whole numbers or floating point numbers. Now, we all know that floating point numbers are not well suited to store certain data types, for example, currency. So the decimal annotation requires you to specify a precision. Precision is the total number of digits before and after the decimal point. So if your salary is going to be at most 9 digits long, which is like up to $9 billion or something, and you want to have 2 or 3 decimals, let's go with 2. Oh, yeah. We got to do precision and then scale. So now we are storing this salary as a 9-2. Let me show you what happens when we run this. So let's go back and see, notice the current data, which is in this format. Now let's go ahead and run. I'm going to keep this data as is so we can compare. So run the app. So we still sent the same value, we still got the same value, but let's take a look at the data store now. Notice that it's stored as a whole number, because since Datastore does not have a true decimal type and we didn't want to use floating point type for storing our currencies, basically we converted our salary in a way to cents. So this is this employee makes these many cents as salary, and then the Catatumbo framework does the mapping and unmapping. So when you're retrieving the value from the data store, it automatically puts, divides it by 100 or 1,000 or 10,000, whatever, depending on the scale. So just to show you what it would look like with a scale of 3. So let's go ahead and refresh. So that's the new entity that we created. Now notice there is an additional 0 because we changed our scale to 3. So when you're retrieving, the catatumbo framework is going to put a decimal right there, which will keep your salary. Now keep in mind, do not change the precision and scale once you have production data, because now if you retrieve this value, it's going to say the salary is only $5,034. So make sure you don't change, uh, especially scale. You can always increase the precision to hold bigger values, but do not change the scale once there is already production data. If you do want to change the scale, you have to pretty much back up and rewrite your existing data before changing your annotation. All right, that covers the decimal annotation and its purpose. Let's see what else we wanted to cover, if there is anything. I think that's pretty much it. Oh, so let's just talk a little about the various data types that the framework supports. Now, Cloud Datastore only supports like a handful of types like whole numbers, strings, binary data, and date time values, and uh, geo points, and then floating point numbers. So in Catatumbo, we pretty much support all the primitive data types and the corresponding wrapper types. Um, you use the wrapper type only if you want to keep null as a valid value. Otherwise, you probably would want to use the primitive type. So we support Boolean, gets mapped to actually Cloud Datastore supports Boolean also. So it gets mapped to Boolean. You can have a single character value which gets mapped to a string in the Cloud Datastore. You can have short, which gets mapped to a long, or the whole number type in the data store. Same with integer. Long is also same. Now float and double gets mapped to the floating point data type in the data store. Big decimal without the decimal annotation again gets mapped to the floating point type in the data store. But if you add a decimal annotation with a and define a precision and scale, it gets mapped to a whole number field like we saw in the example. Strings get mapped to a string. Byte arrays get mapped to blob fields in the data store. Chart arrays map to strings in the data store. Enums, you can have enum. For example, you can have an enum called employee type, which could be full-time employee, part-time employee, contractor, and so on. You can store the enum as is to the data store. That gets mapped to a string based on the enum constants that you define. And then date and calendar objects are mapped to date time values in the data store. Uh, there is a new class in the Catatumbo framework called geolocation if you want to store geo points. And then key, the data store does support key references. For example, in our employee class, we could have a department property, and that could refer to a department entity. In that case, the key of the department is stored in the employee entity. So that's supported. And then we also support lists, sets, and maps. List and set get mapped to array properties in the data store, and map is becomes an embedded entity in the data store. So play with all these data types, and get, familiarize yourself. With that, I would like to conclude this second part. Thanks again for joining me, and I will see you in the next session.